Internal structure of ports in 8051 microcontroller. Since all ports of 8051 are bidirectional, they all have three components in their structure: D-latch, output driver, and input buffer. D-latch hold 1 bit of information, output driver to drive the pin, and input buffer to read the status from pin. Here, the diagram shows a typical 8051 port 1 architecture. TB1 and TB2 are two tri-state buffer. The input to the tri-state buffer is given to the output side based on the status of control pin. L1 is an internal pull-up register. Okay, now let's see how to write data to port pin of 8051. Here, this is the internal diagram of a single pin of port 1. So similar diagram, internal structure would be there for other port pins of port 1. So let's try to write logic 0 to this port pin. So in that case, first in assembly language you have to send logic give the value 0 to port 1 like this, and in C language you have to give logic 0 to port 1 pin like this. So whenever such instruction get executed, since we are writing 0, so internal CPU bus you will get logic 0, and whenever there is a clock, this input is given to the D-latch output. Q becomes 0 and Q bar become 1. So for logic 1, the MOSFET of driver circuit will turn on, and hence you get logic 0 to port pin. So this is how you write logic 0 to port pin. Now let's see how to write logic 1. And so in that case we are sending logic high to the port P1. So again, since it is 1, internal data bus you will get logic 1. Then in this case the MOSFET is turned off, and hence the port P1 get logic 1. So this is how you will write logic 1 to the port pin. Okay, now let's see how to read the content of port pin in 8051. To read the content of port pin in 8051, first we have to make that pin as an input pin. To make a pin as an input pin, you have to give logic 1 to that pin first. For example, if I want to read the content from port P1, in that case, first I will write FF to the P1. That means I am giving logic 1 to the entire port P1, and then I am reading the content from port P1 to register A. We have to do this just to make sure that the M1, that is the MOSFET of the driver circuitry, output driver circuitry, to turn off. Okay, now let's see in animation. So whenever the first instruction get executed, the MOSFET of the driver circuitry goes off, and hence this whatever may ever be the status on the port pin, it will come here. So when the move A comma P1, when you try to read the content of port P1 to accumulator, in that case the read pin will enable this tri-state buffer, and what may ever be the input will given to the output of the buffer, and hence the output of the buffer is again connected to the internal CPU bus. So this is how we read the port pin in 8051.